So hello guys, this is a new Leetcode question. Lowest common binary tree. Ancestor of a binary tree. Okay. So here we are given a binary tree and we just have to return its lowest common ancestor. The lowest common ancestor is the common ancestor between two nodes. And anyone can like in this code example, like if we are given 5 and 1, if we are given 5, okay, 1 minute. Let me just erase it. Yeah, status problem. Suppose we are given two nodes as P, F, node as 5 and 1. So the common ancestor of 5 and 1 is 3. Okay, as you can see it. We just need to find the common ancestor of both. Okay, and suppose we are given the node as 5 and 4. Assume. Then 5 can be its common ancestor. Okay, the LCA. Because the common ancestor of both the nodes is 5 only, not 3, because it doesn't have it doesn't have on the same, like what we can say, same level. It's on a different level, and 4 is a child of 5, so we need to do that. Okay, so yeah, let's solve this. Okay, uh, so yeah, like here we are given the node as 3. Okay, and it has child 5. Yeah, it has child 5 and it has child 1, and 5 has child 6 and 2, 7 and 4. Okay, and it's 0 and 8, the child. So now we are asked that we have to find a common ancestor. As in this, we can see in this question, the common ancestor, we need to find a common ancestor between p is equal to 5 and q is equal to 1. Okay, so we'll first mark the nodes. Okay, so we'll first come here, we'll check the compare the root node. It's not none, so we don't have to exit the loop, and it's not equal to p or q. Okay, so we will just come, we'll compare its left. Yeah, now we got 5. So 5, as we can take the root as a 5. Okay, we compare the node as 5. 5 is same as p. Okay, so we will just keep it as left for now, and then we will check the right of the root. Yeah, it's 1. Q1 is equal to q. Okay, so we will save it as right. So now both are in a different tree. Okay, different subtree, we can say. Phi is a root node of this subtree, and 1 is a root node of this subtree. So the common ancestor between them is the 3. Yes, here we can see the 3. Okay, here we can see the 3. Okay, here is the common ancestor. The 3 is here the common ancestor. Okay, so like we have to return 3. Suppose we are given the node uh, 5 and 4. Suppose, so first we will compare 3. No, it's not the p or q. Suppose p is equal to 5 and q is equal to 4, like here what we're getting. Okay, so we will first check 3. No, it's not. Then we will check the 5. Yeah, it's same as p, so we will keep it as left. Okay, and then check the right node of it. Okay, because we need the common ancestor. Yes, as we can see, right is the right is 1. No, we will go there. We will check that it's left. No, 0. We will check it's right. No. So now we have the left node as 5 and we don't have 4. Okay, so we can again traverse in this, the node that is 5. Okay, we will check if it has a 4 in it. We'll check its left. No, it doesn't have 4. We'll check its right. No. Then we check its left. No, it's 7, not 4. Yeah, here we got 4. Okay, so because like it's, we are just checking for our reference. Okay, it doesn't mean like checking in, doesn't make any sense of checking in the code. Okay, it's for our reference, just to show. So now we just have the now 4 is the child of 5. So common ancestor between them would be always 5 because 4 is child of is a grandson of the 5. Okay, so we just need to return 5 as the value, not 3, because 5 is the lowest into common ancestor that the 4 can get. 4 and 5 can get. Okay, so yeah, let's see its code. So this is the code. Let me just remove this code. Okay, yeah, we can do it from scratch. Yeah, so we have to check if the the root is not null. Okay, so it's the exiting condition. So if the root is null, then we just have to exit it. Okay, or else okay, so if root is in none or our p or q. Okay, so if it's is p or q, then just we will return the root. Okay, so now we will make a pointer left, which will traverse the left subtree. It has self because we have to make an instance lowest common ancestor. Okay, and we will pass it root dot left because we check the left node and the root. Oh, sorry, p and q. Okay, good. Then we will make it right equal to again check the right subtree now lowest common ancestor root dot right comma p comma q. What I was saying, we will check it. Okay, so now we will return the root if uh, if both right and left are in different subtree. Okay, right and left are in different subtree, else we will just return left or right. Okay, so which is not none, we will just return it. Just check it. Okay, invalid syntax. Okay. Hmm. Okay, let me check. Root none type has no. Okay, let me check. Yeah, so yeah, I have converted the Eastman. Let's check it again. Mhm. Common ancestor lowest. Yeah, yeah. Normally making this errors. Yeah, it's always better to solve it. Yeah, let's submit it. Yeah, yeah. So as you can see, 52 millisecond, 46.71. Okay. Okay. Yeah. So now we can solve another question which is based on this. Okay. So let's solve that question first. Okay. Now, so we will solve that question. So this is the today's no, today's daily question of Leetcode. Okay. Step by step directions of from a binary tree node to another. Okay. Uh, so here we are given a binary tree. Okay. Here we are given a binary tree. As we can see here, it is the binary tree. Okay. So here we are given the start node and the end node. Okay. So here we need to return the path from the start node to the end node. As we can see here, we are given the tree. Start node is 3 and the end node is 6. So we need go first go up and then come this way. Okay. So here there are two approaches. Okay. First is making a map. Okay. And second approach is using the LCA concept. We look that we saw just saw. Okay. We can just use this LCA concept here. Okay, so suppose let's start from the top root node. Okay, we will first traverse to the left node first, then the next node. Okay. uh, yeah, then we'll compare this node. Then we are given this 2, 6 and 4. Wait, so we will so now we will first check this pointer. We'll keep a pointer here. Okay, and check if phi is our start or end node. No, it's nothing. So we will just ignore it and come here, check this for 1. Okay. Sorry. So yeah, and then check if 1 is start or end. No, it's not. So we will just ignore this also, and we will go here and check. Yeah. Yo, so 3 is our start node. So okay. So I will we will just save this path in the start path. We will make two arrays here. We will make two arrays. First is start path, and second is destination path. Okay. So here in the start path we will first keep the root node, then the main our second node one, that is, and then third node. That's our start node. Okay. So we got the path from the root node to start node. Then we will just get a now we will just search our destination node. Okay. So destination node we will just search for 5 first. Okay. See, we are not getting a 5. Just ignore it. Just go 1 then 3. No, we are not getting a start path. Okay, so we will just reverse the path. Now we just again go to the uh, root of the node. Okay, then we have 5 here. Okay, then we will compare the 2. We will compare 2 here. Okay, so 2 is not a start node. Okay, we will just give it. Then destination value is 6, so we got 6 here. So our this is our destination path. Okay, so just we are just have to remove now the common numbers, common roots here that we are getting. Okay, just a common roots that we are getting here. Okay, we have removed the common roots, so we will make a. We can just save a common. We can just make a variable called common. Okay, and we will just initialize it to 0. So as we can see here, 5 and 5 both are common. So we'll just increment it 1 and make it 1. Okay. So because we just have to ignore it, we need a path, not this. But this is our connection link, so we have to just ignore it, just for so that we are making the common pointer. Okay, so then we'll check 1 and 2. No, it's not common, so we'll just stop it. Then the level here. Okay, so the length of this will be 2, and this will be also 2. Okay, so here we need to go. 3 is our child node. Okay, 3 is our child node of 5. Okay, so what we can do is we have to go 2 upwards to get to 5. So the length of this is 2. So we will get a save a variable called answer. Okay, answer will have like we here we need to go 2 step upwards, 2 upwards. Okay, so it will be u, and here 2 and 6. 2 is right, 5 to 2 is right, and 2 to 6 is left. So we just have to save it as right and left, and this is our answer. Okay, so let's check the second example here. Okay, let's take a second example. Here, as we can see, we are given a root. Here we are given root 2. Okay, root 2 and 1. Okay, so first we compare. So the start value is 2, and destination value is 1. Okay, so we will first get the route pointer to the pointer here. Okay, first we'll give a pointer here, and yeah, it's the start value. So we will save it. as 2. Okay, then we have to go to 1, and for 1 the destination path will be 2 comma 1 because we requested to go 2, then we will go to 1. Okay, so here both are common, and for getting from 2 to 1 we don't need to go any upwards or anywhere. Okay, so we just need to make a left shift. Okay, so we will reach 1, so the answer will be left 1. Okay, 1 left. So let's see its score. So, as you can see here, this is the code. Let me remove this first. We'll do it from scratch. Okay. So we will make a start path, which will save all the like the direction, the path from the root node to the current start node. Okay. Then we will make a destination path, which will save all the path from the root node to the destination node. Okay. So we will make a function to find a path. Okay. As find path, which will be helper function. It will take the root as node, then our target node, and then our destination and our this start and a path, path array to append it. Okay, so if our node is none, we will just return none. Okay, so let's simplify it. Okay, if our node is equal to our target node, yeah, so we will just return true like we found it. So we'll just break our recursion. Okay. Else we just have to find out the root node now. Okay. So we will suppose first we will go to left. Okay. So in the path we will append left. So it will show us that we need to go left. Oh, sorry, so my bad. A path dot append uh, L. That is our left because we need to return here L as we can see the output here. Okay. Then we will check if our find path can find in the left of that left out on that node. Okay, on the left of the node. Suppose now we are in 1, so we will check for 3 if it's equal target or not. Okay, so if node dot left is true and for a target value for the path, then we will just return true. Okay, return true. Else we will no, we don't have need to go there, so we will just pop it. Okay, then we will just check its right node. So append our right keyword. We'll append a right keyword, right as a keyword here. Okay. And again we will check for the right path, right subtree. Okay. Find path, node dot right, comma target, comma path. Then we will just return true. Okay, else we will just again pop it. We cannot find that in that subtree. Okay, else we cannot find that only, so it's not present, so we will just return false. Okay, false. Okay, so now we will just initialize, we'll call the find path here to get our node, append our start path to get a direction of the from the root node to the start value and destination value. So if okay, uh, node dot value we have to write because it's int target dot value. Okay, root, then our target start value, and our start path. Okay, then again we will call it for our destination path, root comma uh, dest value comma dest path. Okay, and now we will make a common answer. Like we have to check the common things between the both the things. We should get the least common. Okay, so we need to initialize remove all the nodes of the ancestor which is above it. Okay, so we'll make a common variable, like we will initialize a variable called common, which will say all the common pointers, which will point to all the common things. Okay, and our answer. Okay, so we will check while common is less than length of start, so because it should not go beyond it, and length of uh, destination path. Okay, we have to compare it. Common is less than destination path, and both the values should be same, then only we can get the common value. Okay, start path of common is equal to destination path, destination path of the common, no, is same, then we will just increment common. Okay, else we'll just ignore it. Okay, now answer will be answer dot extend our u, because suppose in this example 3 is here, so we need to go 2 up, so will multiply, so we will append extend u into our length of start path minus our common elements. So here we need to go 3 downwards, so common elements are 1, so we'll just remove it, common. And then our, okay, and then we will just another time extend our common from all the common nodes from to the destination. Okay, common to all the nodes on the destination, we will just get it destination path, we get all the path from the destination. Okay, and then just return our value. Okay, join answer. Let's check it. Int has no attribute. Well, okay, my bad. Yeah, yeah, I'm writing sometimes. Yeah, as you can see, it's set up now. Let's check it. Yeah, 67.45. Yeah, it's one of the most optimized approach, I think, that I can get with time complexity of login. Wait, and space complexity of also login. Let's say, we cannot say that. Okay, thank you. Please share and comment if you can get in some better approach. Okay, thank you.